These are the notes for density and buoyancy. Here are the words to know. Density, buoyancy, Archimedes' principle, mass, volume, buoyant force, submerge, neutral buoyancy, displace. Here are the key questions you should know the answer to. How does density determine if something sinks or floats? How can the density of regularly and irregularly shaped objects be found? What is buoyant force? How does it determine if something sinks or floats? What is Archimedes' principle? How does density determine if something sinks or floats? You might remember back in elementary school you may have done a little experiment where you put some things in water to see whether they sunk or whether they float. And this can be explained by using their density and their buoyancy. Density tells you how tightly compact something is. The density of water is 1 gram per milliliter. Remember that? The density of water is 1 gram per milliliter. Circle this right here and remember it. Also, if something is more dense than the surrounding fluid, it sinks. If something is less dense than the surrounding fluid, it floats. So if we put something in water and it is less than 1, it will float. If we put something in water and it's more than 1, it will sink. Write sink or float in each of these spaces to say whether they will sink or float in water. Pause video if you need to. The density of an object will also tell you what percentage of it will be submerged in water. So if we knew something's less than 1, here this is 0.9, we know that 90% of it will be submerged. And if it's 0.5, it's going to be 50%, 0.85, 85%, and so on and so forth. Be sure to write these down in your notes so you have them to refer back to. How can the density of regularly and irregularly shaped objects be found? Now, to find the density of an object, you need to first know the mass and volume. You can then divide the mass by the volume to find density. Finding mass is the easy part. We know that we measure mass using a triple beam balance in our class, and our units for this will be grams. Volume is a little bit trickier. To find the volume, we first need to determine whether it is a regular shape or an irregular shape. If it's a regular shape, we can use a ruler to find out, with a little bit of math, what the volume is. There are equations for this, for cylinders and spheres and cones, and we'll be using mainly cubes and rectangular objects where we just look at length, width, and height. If we have something that's not a regular shape, it is called an irregular shape. And we have to have another method for finding this. And so we have our liquid displacement method. In the liquid displacement method, we use a graduated cylinder and we fill it up with water. We put the object in, we see how far up it goes, and that's the volume of whatever you put in the water. That's called the liquid displacement method because the object we put in is displacing or pushing the water out of the way, and it's the amount that it pushes out of the way is the volume of the object in there. So we need to record the value before and after and then find the difference. Now once we've done this, we can then take our values for mass and volume, however we found it, and divide the mass by the volume to get density. In your notes, you have 2 practice problems for calculating density. Go ahead and try both of those right now, and I'll do the first one with you. Our first one, if you look on there, it has a mass of 45 grams. All right, we know its mass because we can see the G after it. Okay, and we have a volume of 15 centimeters cubed. Now remember, this 3 doesn't do anything to this number. The 3 just refers to having 3 centimeters multiplied together. So that's cubed, meaning it's a volume. And we solve for this. 45 divided by 15. Use a calculator if you need to. But we know this goes into this 3 times. And always write your units. This will be grams per centimeter cubed. Alright, that's our density. Do the next one on your own. What is the buoyant force? How does it determine if something sinks or floats? We need to go back and think again about balanced and unbalanced forces. You know, as this diagram looks very similar to other force diagrams we've looked at. And you know what's going to happen. If we have a gravity force that's greater than the buoyant force, then it's going to sink. If the buoyant force is greater than the gravity, it's going to push up and it's going to go up and float. So that is why we had to learn all that about balanced forces and force diagrams. Another important thing to remember is that if something is submerged underwater, that's my line meaning it's underwater now, water is pushing on all sides. All right, remember we had water pressure before, we talked about it pushes on all sides. However, water will push more on the bottom than it does on the top. And because it has a greater force on the bottom, that is supplying that upward buoyant force. Alright, so we have a greater force here on the bottom than on the top, and that causes that buoyant force. Now we talk about buoyant force, we have to talk about Archimedes' principle. In Archimedes' principle, the buoyant force on a submerged object is equal to the weight of the liquid displaced by the object. And this is very challenging to understand until you really think about what it's telling you. All right, this force, the buoyant force, all right, this right here, put a box around it. All right, the buoyant force, that is equal to the weight of the liquid that's displaced, so pushed out of the way. These are the same. Right? These were equal to each other. So this displaced water here, this weight of water is equal to the amount of force pushing up. And this is useful for explaining a lot of things, including how we can get something that's made out of aluminum or iron to float. If we can get it to displace more water, meaning we can get a greater buoyant force pushing up on it. So, on this drawing, make sure that you indicate we got some buoyant force pushing up here. All right, we have also a greater volume, which we know from density. The more volume we have, the less dense it's going to be overall. But this piece of aluminum might sink if we just throw it in there solid. This one will float because it's displacing more water. And this also explains how we can get huge things like aircraft carriers to float. If you notice, they're very, very wide on the bottom. They displace a lot of water, which means there's a lot of buoyant force pushing up on it. That's how it gets to float, because it displaces all the water that's equal to the buoyant force. That's it for the notes. Goodbye.